Today we'll go through how you can easily deploy and publish a RAG or a retrieval augmented generation application so that it's no longer just running on your laptop, but it's actually published to a website and a URL that you can then share to people. And our application here has two components. It has a React front end and a FastAPI LangChain backend. And we'll be covering two different deployment options, two different services, one being Vercel and another one being Modal. And both of these offer a very straightforward, very hassle-free way to deploy these kinds of applications. And they are also both completely free to get started with. Now this video is a continuation to a previous one where we built this application step by step. So today we'll also be making a few adjustments, a few improvements to the way that the application currently is. With the first being that we are going to make it a lot more responsive by implementing WebSockets and streaming so that we can actually stream the language model output in real time to the user rather than making them wait for the full response to be complete. And then secondly, because the RAG logic is currently being built with LangChain, we are also going to cover an alternative to that without needing to use LangChain and only using OpenAI's API directly. So first we'll be working our way through those few adjustments, and then in the later half of the video we'll be covering the deployment stuff. Of course, if you're only interested in the deployment, then you can always skip ahead. So just to quickly recap where we left off last time, this is the front end of our application built with React, where we can ask questions about our documents in our database. And that's going to retrieve the relevant context from our vector store, which is quadrant in this case, and pass them to the language model to generate the response. And so here we see that retrieved context with the original source, and then here we have the answer. And through this UI, we can also add new articles, new website articles to our database by passing the URL like so and pressing this index instead. Then that's going to scrape this article and add it onto our search index. And the way this works is that this front end is communicating with our FastAPI backend built with Python, where we have these two endpoints. One where the RAG or the Q&A requests are sent, and that's going to return the documents and the LLM answer. And then the indexing endpoint where the URL is going to be sent, and that's going to handle the scraping and uploading of new documents into our database. And so if you didn't see the last video where I went through the code in full step-by-step, line-by-line detail, both for this FastAPI backend as well as the React front end, you might want to go check that out first. But assuming you feel comfortable with the basics of React and FastAPI, here we'll just keep going and we'll continue improving our application and then also looking at how we can deploy it out to the world. So the first thing we'll want to do here is we'll want to modify our API a little to be able to send streaming responses back to our front end so that when we ask these questions, we don't need to wait for the full response to be finished before showing something to the user, but rather we want to be able to show the response being generated in real time. And so to do that, we'll need to adjust this function that we are currently using, get answer and docs, to get the answer and documents before then sending those through the API. So if we look at this function now, the issue is that it's using LangChain and it's running this pretty simple retrieval and answer generation chain. And then it's only returning this dictionary to the API after the chain has finished running. And so for streaming, we'll need to define a new version of this function, and it's going to be an async function. And we can still use the exact same LangChain chain here, but the first difference is that instead of using this invoke method on that chain, we're going to be using this aStreamEvents method. And that's going to give us a generator of events that we can then loop through. And this way we can get this continuous stream of events while the chain is being run. And there are going to be various types of events, and we can get the event type for each of the events from this key here. And there's a few event types that are interesting to us here. The first one being this onRetrieverEnd. And this is the event that we're going to receive after the first step, the retriever step, is going to complete. And so when that's the case, then we want to send something to our API, which is the list of documents, the retrieved context that we get from the retriever step. And we can get that from event data outputs documents. And because this is a list of LangChain document objects, we'll need to convert them into dictionaries first in order to send them through our API. So we'll just do this list comprehension here to get all of those LangChain documents as dictionaries. Then secondly, the second type of event that is going to be interesting to us is this onChatModelStream event, which is the event we get every time there's a new incremental output or new chunk from the language model response. And for each of these events, we'll again want to send that chunk, that incremental piece of the response back into our API. So we'll get that from data, chunk, content. And for both of these, we'll also include the event type in the dictionary that we send through our API so that we can understand what event is being passed. When there are no more events in this stream of events from running our chain, when the chain has finished running, in other words, we'll finally return event type, let's say, done. And then using this signal, we can then know that the response is finished. So this way, instead of just having this one return statement, once the chain has finished, we'll have this continuous stream of these incremental events. We'll have one event when the retriever finished running. And then we'll also have the incremental language model stream return to the API chunk by chunk. And we won't overwrite our previous function. We'll just give this a different name. We'll call this async get answer and docs. And then to handle this kind of stream of events, we'll also need to make some adjustments to our FastAPI code. Most importantly, we'll need to be using what's called a WebSocket. And this is a different kind of communication protocol compared to these post requests. And these post requests work on the more traditional one request, one response model. Whereas if we want more continuous communication between our backend and frontend, then we'll need to be using this WebSocket endpoint instead. And the way we can define these WebSocket connections in FastAPI, we'll need to import from here WebSocket. And then these two will be an async function, so async chat, and then the argument to that function is going to be this WebSocket class that we import. And this WebSocket argument and class represents the open WebSocket connection that's created or opened when we call this endpoint. And while that remains open, we can continuously send and receive messages through this endpoint, through this connection, until we at some point then decide to close the connection. And so the first thing that will happen here is that we will receive the question through this WebSocket from the client side, and then we'll start returning those events from our previously defined function. I will need to import this here as well. And here, if the event type equals done, which is the last event that's going to be returned by our function, then we are going to close the WebSocket, and then we are going to return from the function. Otherwise, as long as we get events other than the type done, the last event, then we're just going to send those through the WebSocket back to the client in JSON form. And we'll also need to import JSON. And this way we can have this kind of WebSocket connection that can have continuous and bidirectional communication between the client and the backend. Now finally, to handle this streaming WebSocket connection, we'll also need to modify our front end, not too much, but slightly. So here in the handle submit, which handles our user inputs, we'll first open the WebSocket like so, and that's going to be US localhost with our WebSocket endpoint. And then using WebSocket on open, so this is going to perform an action as soon as the WebSocket is initially opened, and that action is sending the question, after which we are going to be listening for the events sent back by our backend with the WebSocket on message, parsing the data, the payload in each of those events, and then using those same event types that we defined. So if the event type is on retriever end, then that means we can fetch our documents from that event, and that's going to be in data content. So this key will save the retrieved documents first, and then the second event is going to be the onChatModelStream, in which case we'll append the previous answer with the new chunk. And so this way, for each new event from this ChatModelStream type, we're going to incrementally update the value of our answer. And then finally, once the WebSocket closes, which is handled by our backend, then we are simply going to be set the isLoading to false, which stops our loading indicator or our loading animation when the response has finished. And I believe that's all we need, so that now when we go back to our UI with our updated backend and our updated front end, we can now ask a question. and it's going to stream the response like this in real time, making for a much more responsive user experience. Now, before finally moving on to deploying this application, a few people in the last video asked if I could make a version of this doing the RAG logic without using LangChain at all. So we're going to do that as well now. And so here in our RAG module in our backend, we're going to create a new function, new version of this async get answer and docs function. But instead of using this LangChain with these two steps, the retriever and the answer generation, we're just going to do the retrieval directly with the Quadrant client, and then we're going to do the response generation directly just with the OpenAI API. I think it's going to be quite simple. So for starters, we'll go to our Quadrant module, and here we'll just need a new function for searching. And that's going to be quite simple because the Quadrant client that we import here and that we initialize here, this one has its inbuilt vector search method, so we can use that. So we'll just call this Quadrant search. It's going to take the query as a string. And first we'll need to vectorize that query into a vector embedding, and we'll define a function for that in just a minute. And then after that, running the search is just going to be client.search, and this is the inbuilt method of the Quadrant client. And this is just going to take 3 arguments. It's going to take the collection name, which is just our collection name here, the websites, and then the query vector, that's going to be our vectorized user query, and then finally the number of results, which we'll set at 4 so that it's the same as what we've been using so far with LangChain, and then we'll just return those docs. So simple as that. Now for this get embedding function, we'll also need to do that ourselves, just using OpenAI's API directly. So we'll define a new function or new module for that. So here we'll just define the OpenAI client, and then we can define the simple get embedding function like so, which is just going to do client embeddings create using the Ada2 model with the input text and returning the vector of that text. So now we can just import that in our Quadrant file, and that's then going to complete this Quadrant search function. And then using those docs, we'll also need that async search generation function here in our OpenAI utilities. So we'll also import the async OpenAI client and initialize the async client. And then we'll copy our prompt from here from the rag.py. We can use the same one. Just instead of this LangChain prompt template where the variables are in these curly brackets, only that we'll need to change a little how these variables are handled, because this wrapping them in these curly braces is the way LangChain does it and substitutes the actual values. But we can instead use this standard string template in the Python standard library to create templates. So we'll just wrap this string into a template that we can substitute values in. And when using this template, instead of curly braces, it's going to be a $sign to signal which other variables we want to replace. And then a second function, async def stream completion. It's going to take a question as a string, and then the docs, which is our retrieved context that we'll get from our Quadrant search. So this is going to be a dictionary, and we'll convert that dictionary into a string by joining all the values. So every object in the dictionary is going to have this page content key, and we'll just join all of those into a string. And then we'll substitute the variables in our prompt template by calling this template.substitute, where the context is going to be this context string we create from the document dictionary, and the question is going to be the question from the user. Then we'll just call for the async response, where we'll pass that prompt as a system message with streaming enabled, and then for each chunk in that stream, in this streaming response, we are going to return from this function the content, the text content in that chunk. And actually we'll do it like this, by checking if there is content, because this streaming response contains at the beginning and at the end a few chunks that just contain some metadata instead of some content. So for those we'll just want to ignore them, and then only for those chunks that have actual content, then we'll, if there is content, then we'll yield or return that content. So we'll do it like that. Now finally, going to our RAG module, we'll import these two functions, the Quadrant search from our Quadrant module, and then from our OpenAI utilities, we'll import the stream completion function. And now we can copy this function. We'll use a somewhat similar structure in our new one. Here, of course, now we can forget about this LangChain chain here. Instead, we'll now get our docs from our Quadrant search. with the user question passed in. And then similarly as we do down here, converting each of the LangChain documents into a dictionary, we'll also convert the quadrant search results into a list of dictionaries, like so. Except here, each of the content items in the quadrant search results, in the list of results, is going to have this key called payload, and that's where we get the dictionary instead of calling this .dict method, as with the LangChain documents. But the end result will be the same. Then after doing that, we'll do something similar as here. We'll actually just move this right up here. So now this is basically our onRetrieverEnd event. So we'll just return that from the function. So we'll use the same event names as up here on onRetrieverEnd, so that we don't need to modify anything in our front end to handle these events. And then the content, we don't need this parsing here. We'll just pass the docs dictionary here. So we'll send the documents right back to through our API when this is done, and then we'll start streaming the answer as well. So async for chunk that we get from our stream completion, passing in the user question and the dictionary of documents, will then yield using the same event type on chat model stream content equals chunk. And then the last part, just like before, we'll just return this done event. So simple as that. This is how we can do this kind of a simple vector search and RAG without needing to use LangChain at all. So now we can just comment out this function. And like I said, because we are using the same structure and these same event types, we actually don't need to change anything else in our FastAPI or our front end. So now we can just go to our application, and then here, if we run these same questions, we'll get more or less the exact same behavior and the exact same results. Getting the documents, when we finish getting the documents, and then we stream the response. So now we can finally go through a very simple way to deploy this application, to actually make it live and have a URL that we can share to people. And there's any number of services we could be using for this, but the one we are going to use is Vercel, which is just a very straightforward, very minimal configuration option that you can also get started with for free. So you'll go to vercel.com, sign up, after which your portal will look like this. So you'll have this hobby, which is the free tier workspace with no projects deployed yet. Then there's just a few things we'll need to do here. First of all, you'll need the Vercel CLI, which you can install very easily with the npm package manager that you will already have installed as part of setting up the React application, which we covered in the previous video. So that's just going to be npm install with the global flag to install it globally on your system, and then we can run those deployment commands directly here in our terminal. And now while that's installing, the only thing we'll need in terms of configuration here is for this backend, we'll need a little bit of config. We'll need this configuration file called vercel.json. And it's just going to have some very simple config, mainly about where the entry point to our application is going to be. So we'll need to guide it to this app.py file, which is the main entry point for our FastAPI, what runtime or build to use, and then how to route the requests to that application. And so we'll just need this for our Python, for our FastAPI side of the application. We don't actually need any config at all for the front end, for the React, because Vercel is automatically going to recognize the standard React structure and know how to build and deploy this kind of application. So we just need this vercel.json for our backend here. And then that's actually everything we need to now deploy both of these separately, which we can just do very easily with this Vercel command, which is going to take care of it with the prod flag and with this yes flag to indicate that we can skip any confirmation. Now we will need to run this command separately for our backend and our front-end folder. So we're actually going to write just a minimal bash script to take care of that, just to avoid that little bit of manual labor. So all that's going to look like is it's first going to go into the front-end directory, run this command, then go to the backend folder, run the same command, echo deployment complete. That's our complicated deployment script. Then we'll just open a new bash terminal to run that, and then just run the script, go like this. And so now that's going to start our deployment, starting with the front end and then moving on to the back end. And now that's finished running, so we can go back to our Vercel portal, and now we can see our two sides of the application, our backend and our front end, separately deployed to these two URLs. And for our React app, everything seems to be working okay. And for our backend, we actually have some issues, because there's one thing I forgot about setting up the Python backend for deployment. which is that we are using Poetry to manage our dependencies in the form of these two files. But Vercel doesn't actually recognize these automatically to install those. Instead, we'll need a requirements.txt file to list all the required dependencies for the application in order for Vercel to automatically recognize and install those. But we can do that pretty easily. We'll just go to our backend folder, and then we can run this Poetry export to export the dependencies into this correct format, into this new file. So the format is the requirements text format, and the output file is called the same. And we don't include these hashes, which are used for verifying the correct versions of the libraries, but we don't need them in this case. So we can just run that, and then now we have this file that we need. So now we can just rerun the exact same command, run the same deploy script. So now let's check that out again. And if we now go to our backend URL, we see this detail not found, but that's only because our API doesn't have any default endpoints. We just have these various chat indexing endpoints, but we also have the automatic docs page that's generated. So this way we can go and we can verify that indeed our FastAPI is also now running correctly on Vercel. So simple as that. A bit of configuration for the Python, making sure that your dependencies are correctly listed, and then it's as easy as running that simple Vercel command. However, we aren't quite done here yet, because one issue with the way our application is currently set up is that we are assuming here that they are both running on the local host, but that's no longer the case. Now they are deployed into these separate hosts, and we need to specify here in the allowed origins, as well as here in our front end, in creating the API connection, we need to specify the new URLs that the applications are now hosted on and running on. So we could manage that with some environment variables or something like that. That could allow us more flexibly change them around. But here we're just going to copy the URLs straight from here and hard code them into the application. And we don't need the port number either anymore. So that should do here. And then for our backend, we'll place our front end URL. And then there's one more thing, which is that when it comes to our FastAPI deployment, Vercel actually doesn't support WebSocket communications from one of these APIs, at least in any straightforward way. So this part here with our newly added streaming connection is actually not going to work out, even if we change the URL here. Now we are going to get around that and use another service that's going to allow us to do that in a minute. But for now, we're actually going to revert back to our previous version of the application without the streaming response, just to show how this would work if you were just deploying some API and some front end on Vercel that didn't require WebSockets. So here we are going back to using our non-async chat endpoints. We have set the URLs correctly for our front end and our course in our backend. And so now once again, we can simply redeploy. And now if we refresh our application and ask a question, now we should be getting a response. It's calling our backend at this Vercel host. And although it's not streaming, it is still working like it's supposed to. So Vercel, definitely a very good, very straightforward option for doing these kinds of deployments. So I hope this was helpful in helping you get the hang of it. But now we do also want to get the WebSockets working. So for that, we are going to be looking at another service called Modal Labs. And the basic idea of Modal is that you can run and deploy your functions on their serverless cloud. And the really special thing about Modal is that they allow you to scale up to very powerful compute, up to dozens or hundreds of the best available GPUs on demand, so you can get a lot of compute for a very short amount of time for some data or compute intensive workload, such as fine-tuning LLMs. And then you can also scale right back down, so it ends up being very cost effective as well. Now that's the core bread and butter of Modal. But another nice thing about Modal is that they also support WebSockets for those functions that you deploy. So what we're going to do now is we're going to deploy our backend on Modal instead of Vercel and go through that process. So Modal as well have a very straightforward sign-up process. You can get started totally for free, after which you'll have a dashboard like this. No apps deployed so far. But this is also going to be very straightforward, I would say, just like with Vercel. So for this, we'll just need to change the structure of our FastAPI code here, and just a little bit. And the way we are going to do that is, first of all, by adding the Modal SDK into our Poetry virtual environment. So Poetry add Modal, that's going to install the SDK. And then from that SDK, we're going to import a bunch of stuff. which we'll be using in just a second. And the first thing to do is that we're going to initialize our Modal app, and we're going to define the image, the virtual machine image on which to run that application. It's going to be a very standard Debian Linux image. And then we'll specify how we are going to install our dependencies on that image. And here we can use our original Poetry PyProject file to install the dependencies from that file. And then all we'll need to do is we'll need to just wrap our existing FastAPI code inside this Modal app. And we'll do that with these two decorators, the app.function and then ASGI app. And with these decorators, we'll define the main endpoint function for the Modal app. And then here we can simply just indent all our code inside that endpoint wrapper without needing to modify anything, except for adding a return statement at the very end to return this app, which here refers to our FastAPI application. And this might seem a little confusing, these decorators. Now, if you want to better understand in more detail the Modal application model and how these decorators work, their documentation is excellent, so I highly recommend you go check that out. In this video, for the interest of time, and for the fact that I'm also personally pretty new to using Modal myself, I'm not going to try and give you a precise description of how exactly it works. But for now, I think this is enough to give you a basic idea of how you can wrap your existing FastAPI application inside Modal. One last thing we'll need here is that to import our environment variables from our .env here, we'll need to load them as secrets inside this app.function, and we'll do that with this secrets class that we imported also from Modal, and we'll just load the secrets from env, which is then going to automatically load them from our .env file. And once again, although it's a different approach from Vercel, this is again all the configuration we are going to need to deploy this to Modal. So now we can just delete our vercel.json configuration. We can also delete the requirements.txt file, which we do not need for Modal. And then we can simply call Modal deploy and the path to the application that we want to deploy. So that's our source app.py. And Modal also deploys these applications very fast, so they shouldn't take us long at all. And now that's finished, we can go to these endpoints, and once again we get the not found message as expected. But if we go to our docs, indeed, now it's working correctly on Modal. Now the last thing, we'll of course need to update our front end as well, to go back to our streaming function instead of to go back to using our streaming function, our WebSocket function, and updating this WebSocket address to our Modal address, like so. And now we'll just redeploy the front end to Vercel as well. So here, now that we don't want to deploy the backend to Vercel anymore, we won't run our deploy script. Instead, we'll just go straight to our front end folder and run the Vercel command directly there in our CLI. And now we can also just delete our backend in Vercel. So we go to settings and then way down here, delete, just giving it some confirmation. And so now we just have our front end here left, and then we have our backend running on Modal. And now going to our application again. And now if we refresh our front end again, now we should be getting that streaming response from our Modal API, like so. Awesome. So that's it for this video. If you found it helpful or interesting, I would love to hear about it in the comments below, as well as hearing what kinds of videos you'd like to see in the future, what kinds of topics you would like to learn more about, and I'll be reading those, and I'll definitely do my best to make it happen. And in the meanwhile, thank you for watching this video, and hopefully I'll see you on the next one.